Okay, that will be happening.
Yeah, now it is fine. Okay, so hello everyone. I think Anushka haven't joined it, so no issues. Okay, so this is a Pi Square seminar series we are doing. From last month we are doing it. So this is the fifth presentation by our student Srinidhi Kumar, and the topic is calculus. Not topic from the calculus portion. The topic is differentiation, and we will discuss about the geometric form of the differentiation, and we'll see there how the Srinidhi going to present it. And another thing is that this again, this is from my side. The Pi Square seminar is, hope you know, I'm sending many times the mail, and also who is ever have joined already in the space, and I'm also getting the calendar invitation. So Pi Square is nothing but a place where you, if you want to present something of any from any topics, even it could be ML, data science, AI, or any kind of advanced or basic from maths, stat, or from any kind of from any area you can do. You want to present something, you want to share your knowledge, you can just ping me from anything directly. You can even you can write in. Now we have already a YouTube channel, so you can ping there, or you can ping me here. My mail is there always. So whatever the way, you just ping me. Will let me know. My team is there. Anant is already there, and uh, he will help you. My core team is there. He will surely help you to preparing the slides, or if needed some correction, they will suggest you, and we'll do the. This is the fixed time, Friday 8 p.m. So okay, so that's all. This is for the Pi Square seminar. Yes, Srinidhi, you can go with the video. You can turn on video or without video. So there is 8 people have joined. No issues. We have a big audience on YouTube also. So there is no issue. You can go with this. I'm recording with this session and will live on you. So later it will be on YouTube. Okay. So go ahead, Srinidhi. You can turn on even if you want, or you can.
Yeah. Am I audible, sir?
Yes, you are audible.
So, good evening, everyone who's here. My name is Srinidhi Kumar. I am currently in the diploma level of IIT MBS course. I'll be there for another couple of terms. So, let me get started. My topic today is calculus, particularly differentiation. So, I think all the foundation level students would have learned calculus somewhere. I think it's in Maths 1. But one common thing that we see with calculus is many of the people know the formulas, they know the system, how it works, but they don't know the basics, how the internal is. Like, most importantly, I'm talking about the graphical part of it, the graphical interface of differentiation in general. So today we will focus more on the graphical side. The formulas, I think most of the people know the formulas, how to solve problems, everyone knows that. We'll look at how it actually works, what calculus actually is. So let me. Is my screen visible?
Yes,
Okay.
Srinidhi.
Sorry. Yeah. So what is differentiation? Differentiation, in its most basic form, is just rate of change. The rate at which some things change. For example, speed is in some sense a derivative of distance with respect to time. So a derivative of a function represents the slope of the tangent to a curve at any given point. But before we dive into differentiation, there's one more important concept that we need to know, and that concept is that of limits, because limits is the cornerstone of calculus in general. That's the most basic point of calculus. That's where we get started with calculus. So let me ask everyone just a very simple question. What is the answer to this? Can anyone tell me what is the answer to this? 1 by 0.
Undefined.
Okay, why is it undefined?
Yeah,
Because
you cannot divide anything by zero and it's not defined.
Okay, so let's look at something else. What is the answer to this?
4.
Four.
Everyone knows it's 4, right? But why is it 4? So let's go to the most basic point of mathematics, that is the number line. We'll get started with this. Sorry for the drawing. Sorry. So for example, we have to divide 4 by 2. What is the answer? What is 4 divided by 2, guys?
It's two.
It's two, right? So basically, we start at 0 and we have to reach 4, and we have to we have to see the most least number of hops to do that. Sorry for the unconventional wordings. So we start at 0, we make one hop, we reach 2, and then we make one more hop, and then we reach 4. So this is how we divide 4 by 2. However, what if we have to do 1 divided by 0? Again, we start at 0, we make one hop, and then we are returning back to 0. Then we make one more hop, and then we are again returning back to 0. So that is the problem when we look at 1 by 0, for example. It's not undefined because no one wanted to define it. It's not undefined because mathematician did not want to define it. It's undefined because there's no answer to this in some sense. So that's when we use the concept of limits. So what is the answer to this now? As x tends to 0, what does 1 by x tend to?
Infinity.
Infinity. Why is it infinity? Because for example, I get started with, just quickly tell me the answers. What is 1 by 1?
One.
One.
1 by 10?
Point one.
So, sorry, not 1 by 10, sorry. 1 by point 1. What is the answer?
And
1 by 10 raised to minus 5.
10 power 5.
10 raised to 5. So, do you observe which direction we are going in? As we reduce the values of x, the values of 1 by x increases. And hence we say that the limit as x tends to 0, 1 by x is infinity. So infinity is not an actual number. It's just a concept that we have in our head for a very large quantity. That's why we say that this quantity tends to infinity, right? So when we come to limits, a particular word that we should always keep in mind is almost, because we are never reaching the point 0. We can never reach the point 1 by 0, but we can always reach the point that is very, very close to 0. And we can say at that point the value of 1 by x is very high, so we just conclude that it is infinity, right? So if we just change it a bit, and instead of 0, we have infinity here. What will the answer be? Am I audible?
Tends to 0.
Yeah.
It's zero. Yeah.
0? Same logic, right? As x gets very big, 1 by x goes to 0. So now that we have somewhat a good hold on the concept of limits, let's now dive into differentiation. One more good exercise to do would be to find what is 0 by 0. So,
Determined.
yeah. What is it?
Undetermined.
Okay, we'll get back to that. Okay, why is it undetermined? We'll get back to that. So now let's get into differentiation. Before that, let me just give you a simple story. Suppose I am running a business of transportation, right? So I have a truck that starts at a point A and goes to the point B. And somewhere in the middle, this guy gets fined. This truck driver who's driving from A to B, somewhere in the middle, at this point C, say C, he gets fined. And the police officer there says that the speed of the truck was more than 60 kilometer per hour. Are you understanding the situation here? Are you guys
Yes,
understanding the
yes.
situation? Yeah. So he was
Yes.
supposed to go from A to B, but at this point C, he got caught because the police officer said that his speed was more than 60 kilometer per hour. But the truck driver says that the entire distance was 2400 kilometers and he took 40 hours to cover this. Okay, let's say it's 2000 kilometers and he took 40 hours to cover this. So the truck driver says his average speed is only 50 kilometers per hour. Do you think this is a good justification of this?
No, because it's average speed, not speed at that moment.
Right? Why is it? Because this is the average speed over a time duration of 40 hours. So now the police officer says that no, that's not a good justification. So he says two more points, say D and E. Yeah. This is say it's 150 kilometers. And he took 2 hours to cover this. So the police officer says he covered 150 kilometers in 2 hours. So his average speed should be more than 60 kilometers. His speed at this point was more than 50 kilometers, 60 kilometers. You think this is a good justification now? So he covered 150 kilometers in 2 hours. His average speed becomes 75. Do you think this is a good justification from the police officer's point of view? Sorry. Can someone answer this?
Someone is saying yes. People are saying yes in this case.
Okay. Sorry, I can't see the chat box.
No issue. I'll just tell you.
Okay. So even now, it's not exactly correct, right? Because we want the instantaneous speed at this point C. We don't care what happened between D and E. We don't care about this. We care only about this particular point C, and we have to see what was the instantaneous speed at this point. So, in some sense, if you guys can make sense out of this, let's say we cover it down, we reduce the interval to say 1 minute, and in 1 minute he covered say 1.5 kilometers in 1 minute, so his average speed becomes 90. Even now, technically, this is still not a perfect justification because we are still looking at a duration of 1 minute. We need at an exact point. So this is where we bring the concept of limits that we just learned. So for that, okay, I'll just put limits and you guys will tell me the values. So what is this function going from A to B? Can I call it f of x? Okay. Is it okay to call it f of x? the duration between A and B, the function at which the truck is traveling.
Yes.
So now I know the speed at this point. This is this point D. So this is f of x minus h. Sorry. Yeah. Say this point D is x minus h. So if this point is x, this is x minus h. Yes. And this point is x plus h. So now I know the speeds at x minus h. I know the exact value of f of x at x plus h. I need the exact value of f of x at the point x. So what do I do? What did we do here? F of x plus h was 2000. F of x plus h minus f of x minus h was 2000, right? So this point B here was f of x plus h, and point A was f of x minus h. And we took the distance between them as 2000 kilometers. Is this equation valid? But I can't see this chat box, sorry. So this is the distance traveled from that we are calculating. And now we want h to become 0, right? Because from A to D and from B to E, we actually shrunk the interval. So in some sense, we are only shrinking the intervals and we are bringing it closer and closer and closer to C. So we have to make h go to 0. Yeah. So we are making h go to 0. And what are we dividing this by? Can someone tell me what are we dividing this by? What is this 40 here? What is this 2 here? What is this 1 here?
A change in x.
Yeah, change in x, right? This is x plus h minus x minus h. So if we simplify this, these x's get cancelled. This becomes 2h, and since it is anyway going to 0, we can just call it h. Did you get this? Or let's make it simple. Let's keep it 2h. Did you guys get this much?
Yes.
Okay. So for now, let's forget this part. Let's just leave out this part. We'll only concentrate on this part. So this becomes x minus h, and this becomes x. So now let's make it x minus h. And now we have half the interval, so it's just h, right? Did you guys get the transformation from the 2 points to a single point? We are only looking at this point x now. F of x minus f of x minus h whole divided by h as limit h tends to 0. This is a simplification of that. Then let's just add h on both sides. So this x minus h goes away, and this now, this is the formula of differentiation. I think this is the first derivative formula as well, if you guys remember this. This is f dash of x. Okay, is this fine? F dash of x is equal to limit as h tends to 0, f of x plus h minus f of x whole divided by h. This is the formula of the first derivative, f dash of x. Let's remove all this. Did you guys get the concept?
Yes, sir. Clear.
Okay. So one more important concept that we have to look at whenever we talk about differentiation is the rate of change. So this is the formula of rate of change, right? F of x2 minus f of x1 by x2 minus x1. That is, f of x2 minus f of x1 is the change in the function value, and x2 minus x1 is the change in the actual value itself. So if we just graph it, this looks. So this is a function. Let's call this function as f of x. All right. This is a function f of x. Now differentiation, the derivative is the rate of change. Sorry. Derivative. Whenever we look at derivative, we have to consider this thing, rate of change. So in this case, so can someone tell me what is actually changing here from say this point to this point? So what is changing here from x naught to x naught plus h? Okay, yeah. Uh, so this is the y-axis, right? So the value of y is increasing when we go from x naught to h, x naught to x naught plus h, and x is changing. So in some sense, if everyone remembers the distance time formula, then this is just y2 minus y1 divided by x2 minus x1, right? Yeah. So this is y2 minus y1 divided by x2 minus x1. Now quickly tell me what is y2 here. So it's just f of x0 plus h. And what is y1? F of x naught. And this is just x naught plus h minus x naught, right? Yeah. So obviously x naught gets cancelled. We have just this much. So this is the formula we get from this. This is, if you observe, this is just the same formula that we got here as well. That's the function of the derivative. That's the formula of the derivative in a slightly modified way. We are looking at a different graph here, but the formula is pretty much the same. Yeah. So when we think of the derivative, one thing we have to the actual definition, if you call it, of the derivative is the slope of the tangent to the curve at any given point. Yeah. Slope of the tangent to a curve at any given point on the curve. This is the definition of a derivative. So if we look at this definition, there are a few very important words. One of them being the slope. Second is the tangent, the curve at any given point. Right? So let's look at them one by one. Firstly, we have the point. In this case, we have the point, sorry, not this, x naught plus h. We have our point given point is x naught plus h. We have the curve f of x. This is your curve. Now these two are the simple ones. If we look at now, we have to look at the other two things. That is the slope of the tangent, right? So let's draw a tangent to this curve. Yeah. So this is our tangent, and this is the point where it is meeting, right? If you look at it, it's pretty much vertically above x naught plus h, or vertically above our given point. So the slope of this tangent is what is called as the derivative. So if you observe carefully, this tangent, if what is the slope formula? Can anyone tell me the formula for slope?
Y equal to mx plus c.
That's the equation
Straight
of a
line.
straight line. That's
Okay.
the equation of a straight line. Can you
C
tell me the equation of a slope, someone?
y2 minus y1 by x2 minus x1.
Sorry, you're not audible.
Someone said so, I think.
Yeah, you're not audible. Sorry.
y2 minus y1 by x2 minus x1.
Yeah.
Y2 minus Y1 by right. This is the formula of slope. And a while ago, if you observe, this is the formula we started with for the rate of change. And this got boiled down to this, right? So did you guys get how this whole graphical interpretation of derivatives works? Just remember this line, slope of the tangent to a curve at any given point, and at some level everything boils down to this one line itself. Obviously you can't solve every problem just using these basic formulas, but it's good to know the concepts, and this is how it gets started. Let's get back here. So we looked at this instantaneous rate of change, limit as this, we used it as x plus h minus f of x by h, right? So this is used here as delta x, f of x plus delta x minus f of x whole divided by delta x. So we used it as f of x plus h minus f of x whole divided by h. So this is how we get started with differentiation. Obviously, I think we would have used a lot more here. I think even in maths 1, there's a lot more differentiation than this. But it's important to know this is where we get started. Oh yeah, you can just look at this example once. See, this is the graph we drew. This is, yeah. So this is the point, this is the upper point, this is the lower point. This is the slope we have. F of x plus h minus f of x. That's the whole thing we got to. So now that we are good with the first principles, now that we know the concept of differentiation, let's go a little bit above this. I think most of the people would have seen this, right? Tell me anyone who has not seen any of these rules. Anyone who's seeing this for the first time?
No.
I think anyone with at least up 12th would have seen these rules some or the other point in their life. So these are the most common rules.
Yes, yes.
I think the only confusing rule here might be the quotient rule. If someone doesn't know how to derive it from the product rule, then might be confusing. But other than that, it's a pretty easy thing, right? So let's go one step further. Let's use the product rule, and we'll use our own understanding of mathematics to now derive the power rule here. So let me clear all this first. All right. So can someone tell me the product rule? Yeah.
d by dx of u into v.
Okay, just change it to f of x and g of x. We should be good.
Okay, so that is equal to f of x into g dash of x plus g of x
Sorry, f
into
of
f
x
dash
into
of x.
g
G
dash
dash
of
of
x, is
x plus
it? G
g
of
of
x
x
into.
into f dash of x.
Anyone who doubts it or has any confusion in this? Okay, I take that for a no. So this is how we get it. D by dx of f of x into g of x is f of x into g dash of x plus g of x into f dash of x. Okay. We will use this rule to derive this. What is, what is this? Anyways,
N into x to the power of n minus 1.
sorry, n into.
X to the power of n minus 1.
Everyone agrees on this? Yeah. Okay, let's go back to this formula that we used. So using this formula, how do we derive f dash of x square?
Multiplying them.
What will be this? Limit. What will be x plus h? What is f of x plus h when x is equal to x square? This just becomes x plus h the whole square, right? Wait, let me just write it again. Okay. Yeah, f of x is equal to x square. So what is f of x plus h? X plus h the whole square minus f of x, that is x square, and the whole thing is obviously divided by h, right? Are we good with this?
Yes.
Should possibly change that f prime x squared to f prime x itself.
Oh yeah, sorry. Okay. Yeah, are we good with this now? Just place it here. Yeah, better. So now we have x plus h whole square minus x square whole divided by h. And obviously you have to say this is, see. Yeah. So this is the formula we get, x plus h whole square minus x square whole divided by h. So what is x plus h whole square here? Can someone tell me this quickly?
You want the differentiation after
No,
applying
no,
or
no, 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 no. I just want the expansion of x plus h the whole square.
x plus h into x plus h?
Usually a plus b whole square.
No, no, a plus b whole square. Yeah. So this just becomes x square plus 2 into h into x plus h square, right? Yeah, are we good with this? Okay. Now, if you observe, this x square gets cancelled out. So this just ends up becoming. Okay. Are we good with this much? Okay, so it's 2hx plus h square, and we have a h in the denominator, so let's cancel out these one by one. This just becomes 2x, and this just becomes h. And now this h goes away. This is what we end up with. Limit as h tends to 0, 2x plus h. Now we can put h is equal to 0. So now this h becomes 0. And at the end, we just get which is equal to 2x.
2x.
So everyone knows the differentiation, right? Differentiation of x square is 2x. Everyone knows this. Similarly, what would be the differentiation of x? Let's just do it here.
1.
Yeah. Sorry. F of x is equal to x. So what does this become? F of x plus h becomes?
Just x. Just x plus h. That's it.
Yeah, perfect, perfect. Just x plus h. And f of x becomes just x. And now we cancel out the x's. So this just becomes h by h, which is equal to 1, right? Yeah, is this right? Differentiation of x is 1 and differentiation of x square is 2x. So now we will use this and we will get to x power n. And for that we will use the product rule. So now let's take what is f dash of x cube?
3x square.
Yeah, but can you tell this without using the formula? Because this is what we have to prove here. This is what we have to get to. So, for example, we would have had to expand this. This would become a power 3 here. X plus h the whole cube minus x cube whole divided by h, and that would be a long process. Instead, can we just write this as
Okay, 3 into x to the power of 3 minus 1.
yeah. So again, you're just using this formula, right? You're just using n x power n minus 1. Instead, can we write x cube as say f of x is equal to x cube. Can we write this as x square into x? Is that right?
Yes.
So now we have f of x is equal to x square into x. So what is f dash of x here? Use the product rule here. Use this rule. D by dx of f of x into g of x rule.
Okay, so it would be x square into 1 plus
Okay.
2x
Slowly,
into
slowly, slowly,
x
slowly. X square into 1 plus,
plus
yeah,
then 2x into x.
2x
That's
into
nothing but 2x square. Yeah.
2x into x, is it? Yeah. Okay. And this is nothing but 2x square. And this
Yes.
is nothing but x square. And now what is the sum?
3x square.
3x square. So we used x square and we used 2x square to get to x cube, right? Sorry, we used x and x square to get to x cube. Is that right?
Yes. We applied the product rule there.
Yeah. So anyone here who is familiar with mathematical induction technique to prove a solution? Or anyone can just give a random guess here. What is the mathematical induction? Okay, n minus 1. Yeah, in some sense you're right. So mathematical induction, what we do is we prove that if a particular solution is true for n minus 1, and that same thing is true for n, Then we generalize this and say that we can take n as any number, and if n minus 1 is true for say 10, if a particular rule is true for n is equal to 10 and n is equal to 11, then it would be true for every value of n, because we can just generalize this formula. Just write it down here. This is what is mathematical induction. So if we can prove that a rule is true for n minus 1, and using that, if we can prove it for n, then we can use n to prove n plus 1, if you're getting what I mean, right? So let's use this, and let's say f of x is equal to x power n. Now we use this to find out f dash of x. So remember what we did in f of x is equal to x cube, where we use x square into x. So what would we divide this into? X power n. What can we write these as? X power n as?
X divided by x to the power minus n. No.
Better
Just
think about like a product, right? So
yeah, as a product. Exactly. Understand the product here. So for x cube, we used x square into x.
Yeah, so
Here
x
also we
into,
will be using x. Here also we will be using x, but what else do we use with it?
we multiply x n number of times.
Yeah. We can use this as x power n minus 1 into x. Is that right?
Yeah.
Is this right? X power n is equal to x power n minus 1 into x. So now let's use the product rule here. All right. So because we are using mathematical induction, we are assuming that this rule right here applies for n minus 1, for x is equal to n minus 1. So when we take x power n, we are assuming that n minus 1 already satisfies this d by dx rule. So using that, let's find out this. What is f dash of x now? Use the product rule now. Okay, this becomes is that right? And in this case, what is f of x? In our case, it's x power n minus 1. And what is g dash of x now?
One.
G of x is x, right? So just for
One.
simplification. Okay, let's not use let's use g of x into h of x, just to not confuse with f of x here. Yeah. So what is h dash of x now? What is h dash of x? 1, correct?
Yes.
And h of x is x. Now, as I already told, we are already assuming that this g of x satisfies this d by dx rule, d by dx of x power n rule. So what now becomes g dash of x? Use this rule here. Use this x power n rule here. This becomes n minus 1 into x raised to n minus 1, right? Sorry, n minus 1.
N minus 2.
Is that right? Or have I gone wrong somewhere?
no, that's fine.
Okay. So now that we have this, so now this becomes x power n minus 1. And what is this now? X into n minus 1 whole power, whole into x power n minus 2. So here let's take an x common here. Let's n
You
minus
can
1
just pull out n minus 1, multiply x with x for n minus 2, right?
sorry.
You can just multiply x with x for n minus 2. So it becomes n minus
Yeah,
1 times x
yeah,
for n minus
exactly. So what is this now? Let's leave this n minus 1 as a constant. And what is the remaining part now?
So now it becomes x power n minus 1.
X raised to n minus 1. Yeah, are we good?
Yes.
Okay. Okay, so now what can we take common in this?
X
X to
power
the
n
power
minus
n
1.
minus 1.
Exactly. X power n minus 1 is common. And what is left from this
1 plus n minus 1.
1 plus n minus 1? Yeah. So what does this come down to? 1 gets cancelled.
Yeah.
And so what do we get now? Finally, what is the answer?
N into x power n minus 1.
N x is to n minus 1. Yeah. Is this the formula?
Yes.
Yes.
Okay. So what did we just do? Can someone explain? What is the technique we used here?
We just applied product rule there and just simplify the steps.
Yeah. So we used mathematical induction. We started with a property that was true for n minus 1. We just considered it true for n minus 1. And we use that to prove that it is true for n. And since it is true for n, we can just replace n with, or we can just replace n with n plus 1 here, and that will apply for n plus 2, if you know what I mean. So we can keep changing n, and this applies for every value of n. So for this, obviously, we needed a base case. For the base case, we proved that if x and x square is true, then x cube satisfies this formula. So that base case we used here, and we got to this formula. And we proved that f dash of x is equal to n x power n minus 1 is actually true. Anyone who has a doubt in any of the steps here?
No doubts.
Okay, anyone else? Okay. So
Excuse me.
obviously, yeah. Yes.
Why again we have used n into x power n minus 1 in step number 2.
This,
Yeah. Yes.
yeah. So
That is what we want to prove, right?
yes. So this is why it is called a proof by mathematical induction. We are considering that this rule that we used here is actually true for n minus 1. So if it is true for n minus 1 and I am able to prove that it is true for n, then if it is true for n, then I can prove that it is actually true for n plus 1. You're understanding the thing, right? So if this
Yes.
is true for 1, and then I can prove that it is true for 2, then I can take 2 in this place, and I can take another number 3, and I can put it here, and I can say it is true for 2, so it has to be true for 3. And
Oh,
going this way, I can prove that it is true for every number that exists. Got this?
yes.
Okay.
Doesn't it
For
tie us to only
yeah,
natural numbers, by the way?
sorry,
Doesn't this process tie the whole thing to natural numbers only?
not exactly.
How do you generalize this idea to, for example, if I wanted derivative of x power half, for example?
Then we'll have to prove the base case here. So we'll have to prove that, for example, x power minus half is actually true for this.
Hmm.
This
What if
property is satisfied by
I,
x power minus half. Yeah.
that's fine. But what if I wanted to find derivative of x power root 2, for example?
I'm not sure about that. I think that would be an overcomplicated process for that. Yeah.
No issue, go ahead.
Yeah. Thank you. Okay, so everyone understood this whole thing that we did, right? Any doubts here? Okay. Okay, so I don't think we really need to know the applications of differentiation. I think we all know it, how much it is used everywhere. I think most of the students would already be using it, especially anyone who's in the IITM degree would already be using it in various parts. So I think this brings us to the end. Also, the question that I asked in the beginning, why is zero? What is 0 by 0, anyways?
Someone said undetermined, right? I think.
Okay, yeah, it is. It is an indeterminate form. So the answer is right, but can someone tell why it is indeterminate?
0 by 0 is different from something by 0. There
Okay,
is
why
some
is
kind of
1 by 0 not
difference
undetermined then?
in it.
What is 1 by 0 then?
1 by 0 tends to infinity,
Yeah, it tends to
and
infinity, right?
it's not that we can't exactly say it is undefined.
Okay.
It's some kind of absurd thinking.
I mean, you're partially right because 1 by 0, sorry, 1 by 0 is considered as undefined. It's not considered as indeterminate form because you can still determine it. So if you guys remember the number line we drew at the beginning, so when you, for example, consider 4 divided by 2, I can make one hop, reach 2. I can make one more hop and reach 4. Everyone is agreeing with this? This is why 4 divided by 2 is equal to 2?
Yes, yes.
Yeah. However, can I start at 0? Can I start at 0, make one hop, and where do I reach? If I take, say, 1 by 0,
Get back to
It's
zero.
you get back to 0. I make one more hop, I again get back to 0.
yes.
This is the process that will continue. This is why 1 by 0 is undefined because you can make infinitely many hops and you will never actually reach one. But when you look at the limit, then we take a very small value, say 0.001, and at some level we can make hops and we are actually increasing. We are actually going towards one. Even though we are going very, very slow, we are actually going towards one. That's why 1 by 0 is not considered undefined, indeterminate. It's considered undefined. But what about 0 by 0? I am at 0. How many hops do I need to actually reach 0?
Zero hops.
Okay. Can someone tell me the answer? 0 hops. Anyone? Anything else?
You could definitely take as many hops as you want, by the way.
Yeah, I can take one hop. I'll still reach 0. I can take two. I'll still reach 0. And I can have infinite hops and I will still reach 0. So if you get back to this 4 divided by 2, it's not just that 4, you need 2 hops, but you need exactly 2 hops. Right? You can't take 3 hops because if you take 3 hops, you actually cross it. If you take only one hop, you are still at 2. So the answer is not just 2, but 2 is the only unique answer. But when I take 0 divided by 0, there's no unique answer. 0 to infinity minus infinity, everything is the answer. That is why this is considered as indeterminate form and this is not even a limit. So I think other indeterminate forms, if you want to know, I think 0 by 0 is one. Infinity by infinity is one more. I think infinity minus infinity. If anyone has read or studied like series or sequences, something like that, infinity minus infinity is one more indeterminate form. So these are all the indeterminate forms. Any doubts? Okay, I think that brings us to the end of this. So today, what did we learn? We started with limits. We understood what a limit is and how a limit is the building block of calculus. Then we slowly went into differentiation. We understood the derivative, rate of change, slope of the tangent to a function. We understood that graphically as well as using a formula. And then we did something that I think very less people would have tried before. We proved x power n differentiation, and finally we looked at 0 by 0 and why it is an indeterminate form. So thank you so much. That brings me to the end of this presentation. Thank you all for joining. Thank you.
Okay, thank you,
Srini,
Srindi. So, anyone has any questions regarding this presentation, or I mean, anything you want to ask Srindi about anything? Okay.
thanks to Srinidhi
Thank you
because
so much.
I really liked the session today, and I never before I haven't attended this type of session, and this is my first session, and I really liked it, and it makes me so curious to attend some more sessions like this. Is there any way to connect with you through a LinkedIn?
Okay. Srindi is asking you, I think.
You're asking me? Yeah, I'll put my LinkedIn in the chat box. Yeah.
Yeah, definitely the presentation was good. There were some fresh views on exactly how we can look at a derivative part, right?
Yes,
The
yes.
geometrical approach, and some unconventional but yet quite interesting, perceptions. Like, for example, why we have that indeterminate form and why not uh, undefined, right? So that is good enough, actually. Yeah. So, well, any other questions anybody has? I
Um,
think.
Well, I would like to give a feedback. Srinidhi Kumar, the session was really good. And I really did not know about certain things. And I also give wrong answers, I believe.
Okay,
But
that's
I
nice.
actually got to visualize the stuff of the formulas that you just derived using graph and all that. So thank you, Srinidhi Kumar, for giving us a great view of differentiation.
Yeah, you can
Uh,
also actually provide your feedback through the Google form, which has been provided by Shubham sir, right? In the chat box, you can see that. Please provide the feedback through that, okay?
Sure, sure.
Yes, Suniti, go ahead.
Sorry.
You're saying
Yeah.
something.
So I would just like to say that I think from the childhood we have seen math so much, and we are so delved into the formulas and the working and solving problems that we have actually forgotten how the basics work. How the most at the most basic level, everything actually comes down to just number line. Everything, even maths itself, was formed only to solve real world problems, right? So I think a real world approach is what we need today to understand maths. And most people say maths is difficult. I think that's the reason people think maths is difficult, because we only see it on the paper and not around us. So that's something I would conclude by saying. Yeah.
Yeah, that's a good
Thank you
point,
so much.
Srinidhi. Okay, so, well, thank you to everyone. I think that brings to the end of the session. If any questions from anybody, otherwise we can wrap it up. Well, no.
Okay.
Okay, Srinidhi, thank you very much for the presentation. It was really a nice one, right?
Thank you so much.
So that'll be the end. Good night to everyone. That'll be,
I have a question.
yes, Kiran.
Yeah.
Is this the first time of launching this seminar series? Previously,
Yeah,
I never.
yeah.
It was.
This term is the first one. I think with, I mean, the series is renamed to Pi Square. Earlier, it was, I think there was some other seminar which was being taken up. Shubham sir can specify that.
Yeah. That the series name was Math Stat Academic Cell.
Okay.
Math acad-
So yeah, so previously it was a broader, like it have lot more events also, but the Spy Square seminar is just part of that, and that's why it's renamed. So this is just for giving the talks and seminar. And previously it was even Olympiad, some other events also were there in that cell. But in
Hmm.
this year, in Pi Square is just for here. This place is for uh, giving the talks, presentation, and seminar.
Okay.
Where can we
Okay.
find those videos?
Sorry,
So
sorry.
these videos will be, yeah,
Where
he's
can we
asking about
find
the
those
videos actually.
previous videos?
Yeah, so video is will be available on YouTube. I have already, if you are getting this through, if you are in G Space or in, I have sent a mail regarding this. In that, four presentation video which is on YouTube available there. In that mail I have mentioned. You can just click on subscribe. Also get that mail every time the videos, or the next announcement. The next announcement I will give this video link. Upcoming Fridays. Fridays.
Right. So I think that answers your question, Kiran.
Yes.
Yeah.
The thing
Yes,
is
sir.
that please provide us feedback to if we want to some, if you need some change or improvement, just give us, let us know via the G form. Okay. And if you want, anyone want to know other things, please let me know. Thanks, Srinidhi. Thank you so much for a wonderful session. It's really good and a kind of brush up session. Thank you
Yeah.
so much.
Thank you. Thank you so much, sir.
That'll be all then. Good night to everyone. Right.
Good night. Good night, everyone. Yes.